Hi folks, this is number 6. What's the minimum energy required to decompose this much phosphorus trichloride according to the reaction below? The molar mass is given. All right. The phosphorus trichloride. If you want to decompose, what does that mean? That means you're going to follow this chemical equation. This is a chemical equation where this thing turns into two different things. 4 moles of this turns into 6 moles of this and 1 mole of that, so 4 moles turns into 7 moles. This is getting decomposed. Now, I want to decompose this, and it requires 1,207 kilojoules of energy every time you run this reaction. So that means if I have 1,207 kilojoules, and that's required for 4 moles of PCl3, and I have 23 grams of PCl3, then I'm going to have to use this fact that 1 mole of PCl3 is equal to 137.32 grams. It's that many grams per 1 mole. 137.32 grams of PCl3. Okay? Moles PCl3 cancel. Now I have to get rid of the grams. I have 23 grams of PCl3, not associated with any other number. So the grams PCl3 cancel, and I have kilojoules at the end. Is that what I wanted? I wanted the minimum energy, so that is going to be in joules or kilojoules. So this is good. Kilojoules is the only unit left. That is a unit of energy. Let's do 1,207 times 23 divided by 4 divided by 137.32 on the calculator. 1,207 times 23 divided by 4 divided by 137.32. That gets me 50.54. Significant figures, there are 2 significant figures. So that gets me 51. That gets me 51 kilojoules. Positive or negative? Let's see. The energy required. Now, decomposing this is obviously positive, so that means this is also positive. By the way, in WebAssign or in the actual quiz, if you must type in an answer, if you must type in an answer, you do not have to put the plus sign on the front of it. I'm just putting it here so that you understand that energy that is required is going to be positive. Energy that is released is going to be negative. Okay, number 7, the law of what states that energy can neither be created or destroyed. That's the first law of thermodynamics, folks, also known as the law of conservation of energy. The law of conservation of energy. It's the first law of thermodynamics. Just for your interest, the second law of thermodynamics ends up saying that every time you convert energy from one form to another, you're going to lose some energy as heat. You are never going to win in the conversion of energy. You experience this whenever you drive your car to work. The car's engine gets very hot, doesn't it? You lost that energy. That's all just lost as heat. It ends up being the case that the efficiency of your car, efficiency in turning the energy inside the gasoline, that chemical potential energy, into energy of motion for your wheels, that efficiency right there, it's very low. It's something like 25% for most cars. Kind of disappointing, right? Anyways, number 8. What volume of benzene is required to produce this much energy according to this reaction? So this is a negative delta H of reaction. You will recall from your WebAssign and from your textbook that H means the enthalpy. Usually, in most normal cases, enthalpy is the same as the heat. When I say most normal cases, I mean whenever the pressure is constant. And if you're doing an experiment or burning something just in open air, then the pressure is constant. The pressure is always the atmospheric pressure. So In Los Angeles, it's usually 1 atmosphere, and the pressure is always going to be 1 atmosphere if you're doing an experiment or burning something just in an unsealed container, just in the open air. So most of the time, delta H means just heat, but officially delta H means the change in enthalpy. Now, enthalpy is a quantity that refers to the total energy, and this goes a little bit beyond internal energy because the enthalpy includes the energy that is just lost as heat or disorder. Okay? But that's not important to know for this question. What's important to know for this question is it's this much energy that you get from 2 moles of benzene. So their question is, how much energy do you get from how many milliliters of benzene do you need for this much energy? Okay, so if it's this much energy for 2 moles, then how many milliliters is it for this much energy? They're asking for volume. Volume is measured by liters or milliliters. So I'm going to start with milliliters. Here I have 0.88 grams per milliliter. So here, let me give you a clean sheet here. 0.88 grams per milliliter. That means 1 milliliter is 0.88 grams. Okay? 1 milliliter is 0.88 grams. And I need to get rid of this grams. So here's some grams, 78.11 grams. 78.11 grams are in 1 mole of benzene, 1 mole of C6H6. Okay, so the grams cancel. And now I have to get rid of these moles. Now, 2 moles of benzene give you this much energy. So 2 moles of C6H6 give you negative 6278 kilojoules of energy. All right. So there we go, moles. All right. And what do I want? I want to produce this much heat. I want to give off this much heat, 12.5. 12.5 times 10 to the third? Okay, that's weird. I will change this for you. So it is I will make it 1.25 times 10 to the second for you. I mean, wait, 12.5. This is 12,500. I will make it 1.25 times 10 to the fourth for you. This is a typo, all right? So for now, I'll just keep it at 12.5 times 10 to the third kilojoules. Okay, so the kilojoules cancel, and we only have milliliters left. That's good, because they're asking for volume, and that's usually in milliliters or liters. So I got 78.11 times 2 times 12.5 times 10 to the third. Divided by 0.88 and divided by 6278. Divided by 0.88 divided by 6278. You'll notice that I ignored the negative sign. I'm just going to use the context of the problem to figure out if the answer should be negative or positive. Okay, baby is here. Excuse me, folks. All right, now 353 is what I get. The significant figures, there are only 2 significant figures, so it should be 350. So 350 milliliters. Now, this was negative. This, in the problem, it was given as negative, but, I mean, in problem it was given as positive, but it really means negative. You have to just understand that, because we're producing heat. So whenever a chemical reaction produces heat or gives off heat, in chemistry we consider that negative. So that was also negative. So the answer should be positive 350 milliliters. Is it very important that you understand the signs in this particular calculation? No. Why? Because there's no such thing as a negative volume. You can't have negative 350 milliliters of anything. You can only have positive or 0. You can't have a negative volume in this universe. So just a little bit of common sense at the end will get you the correct sign. And that's it for number 8. Baby is here, so I'm going to stop this video and do the next problem separately.